Good morning, everyone, and welcome to our last day of this unit. It's a quick one. Uh, the only thing we have left is U substitution, which we already learned, but these are just a little more difficult U substitution ones. So let's look at the first one. Tan cubed 5x, secant squared 5x. What are we going to do? So you got to think, can we let U be 5x? So again, I'm going to start writing in. I'm going to be wrong because du equals 5 dx, and then we're still left with something of the integral of tan cubed u secant squared u, and that really hasn't helped us at all. 1/5 out in front. That doesn't really help us. So, okay, that doesn't work. Let's get rid of that. What are we going to do? Well, with these, it's kind of guess and check a little bit. Let's talk about what it could be and why, and then see if it works. So if we think about this one, u tan or secant. If I let u be tangent, what's the derivative of tangent? Secant squared 5x. So we're going to actually let u be tan of 5x. And then du, derivative of that is 5 secant squared of 5x. That's the chain rule. Derivative of the outside, secant squared. Keep the inside the same, 5x. Derivative of the inside, 5x. Put the 5 out in front. So now we can dx. And so now we realize that if we divide by 5 here, we can get rid of that. So we're going to get 1/5. So we come down here. 1/5 the integral of tan 5x, so it's u cubed. And all of this right there is taking care of that. So du. And look how easy this is. 1/5 u to the 4th over 4 plus c. We're going to get u to the 4 over 20 plus c, and we plug back in. Tan, oh, that's awful tan there. Tan to the 4th of 5x over 20 plus c. That's our answer. So when you see tangent and secant, you should probably start to think of it and figure out how that works. Now, of course, I'm going to go to this one and then go to the next one where we're not going to be able to do that. So we have here secant cubed of 2x, tan 2x. We know that if we let u be 2x, it's not going to work. So that doesn't help us. So what can we do? Well, let's make what? What do you think? U be, well, let's try it. I only have a certain tan x here. So, if we let u be tan x, tan 2x, du is secant squared 2x dx. And that helps us get rid of this, and it helps us get rid of 2 of those, but we're still left with a secant 2x. It doesn't help us. So, erase it again. Let's see what it is. Well, I know I had a secant squared there and a tan there, so that does help a little, but I'm still left over with a secant. So let's actually split it up. And what I mean by that is, can we rewrite this as secant squared of 2x, secant 2x, tan 2x dx? And if we do that, then maybe we can let u be something. And so let's try to. And so the issue is, what the heck do we make u and du? So the reality is that how is secant x related to tan x or tan x related to secant x? Either way, we know that the derivative of tan x, or secant x, the derivative of that equals secant x tan x. And that's the main point right here, is that the derivative of secant x is secant x tan x. Look at what we've got here, secant x and tan x. So if we let u be secant x, 2x, excuse me, and we let du, well, the derivative of secant x is secant 2x tan 2x, keep the inside the same, multiplied by the derivative of the inside, which is 2. Then we're going to get du over 2 equals secant 2x tan 2x. And we've got this taken care of then. So then what is u? Oh, well, we got to have a u squared. I mean, we know what u is, but how can we rewrite it? We've got u squared. So that 1/2 the integral of u squared du. And we can easily take the integral of that, 1/2, no longer the integral, let's go here, u cubed over 3 plus c, you get u cubed over 6 plus c, which then equals, if u is secant 2x, is secant cubed 2x over 6 plus c. And so there it is. And so I know that this wasn't necessarily straightforward, this one, and I know that it wasn't clear, but you do have to kind of guess and see which ones work with that. So one of the jokes for today, what kind of movies do pirates like? R-rated movies. So for the next one, cosine cubed x, usually you would say, no, I know exactly what I'm doing here. Cosine x, du is sine x, and then you get stuck, you go, okay, we don't have a sine x there, so clearly, go back to the drawing board again. Such a pain. If I just do it right the first time, then it wouldn't be nearly as much fun. Well, what do you think? Well, we have to think of something. U can't be cosine x because we get a du equals sine x. So again, we sit here and think, how can we break up this? Well, we're going to break it up into probably the only way we know how, cosine squared x, cosine x. And so we sit there and go, okay, if we know we need a sine x, we know u has to be cosine x, or we think that at least, what can we do here? And hopefully one of you are thinking right now that, well, we know Pythagorean identity, that cosine squared plus sine squared equals 1. And thankfully I'm just praying that one of you guys realize that cosine squared x plus sine squared x equals 1, that we can change that cosine squared x is 1 minus sine squared x, cosine x dx. And now we sit there and go, there's the cosine x and the sine x. What are we going to let u be then? But in this case, we know that u has to be sine x instead of cosine x. And now that can make a little more sense. I'll bring that down here. We have 1 minus u squared, and we've taken care of that, du. Well, that's fairly straightforward. U minus u cubed over 3 plus c. And now we got u is sine x minus sine cubed x over 3 plus c. Wow, and if you could see that, it would be even better. And there it is. So when you have something where you know that a trig function is going to give you another one, how can we break it up and what can we use it with? And for the last method that we're going to learn for u substitution, and yes, there is a back, but for the last method that we're going to learn, or the last trick, should I say, is this one. So u must equal what? Well, it has to equal what's inside the square root, x minus 1. So du equals dx. Well, that's not going to help us, is it? Because x squared is here, and right now we've got the integral of x squared, square root of u, du, but we can't have a du here because this is not in terms of u. Oh boy. So, yeah, you think and sit there and go, well, I notice here we can solve for this. X equals u plus 1. And so if x equals u plus 1, then we know we have the integral of u plus 1 squared times u to the 1/2. So this x squared, we just plugged in there. So u plus 1 squared, u to the 1/2 du. Now, yes, this becomes a little bit of a pain because you do need to expand that out. And now we can sit here and distribute. So we get u to the 5/2. You need to add exponents, plus 2u to the 3/2 plus u to the 1/2 du, the integral of all that. And now, yes, take the integral. U to the 7/2 over 7/2, 2u to the 5/2 over 5/2, plus u to the 3/2 over 3/2, plus c. And we're going to just, I'm going to finish writing this out so that we flip and reciprocate here. So we're going to get 4/5 u to the 5/2 and 2/3 u to the 3/2. And of course we can't be completely done yet. That would make it just way too nice. We have to now plug in what u was. U is x minus 1. And if you really wanted to get fancy, that didn't work very well. If you really wanted to get fancy, you could turn those all into square roots and powers. We're not going to do that now. Thank you to my wife. I have 2 jokes today.
From my corny middle schoolers.
What do you call
A cow with no legs.
ground beef?
Ha 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 ha.
Those are 2 of the better ones, I gotta say, though, from what you guys are used to. So the last bit that we're going to do here is trig functions, inverse trig functions. We're not going to take a lot of time here on these. We'll go over them in class. So the one thing I did want to show you is just how to do these. I'm not going to explain too much here. See that we have 1 plus x squared. That's what we're going to use as tangent. So this is a tan 1. And a is 1. 1 squared is 1. U is x. U squared is going to give you x squared. And the one thing that you do need to do is find du. And we get dx here. So we got dx, dx here. So when I go to substitute in, I'm going to get dx over a squared plus u squared. Sorry, du, I meant to say. Du goes here. Replaced it. And now we're going to just follow what it says here. A was 1, so 1 over 1 tan inverse of u, x over 1, plus c. And we could just rewrite that as tan inverse of x plus c. It's that simple. I'm going to do a couple out, pause it. I'm going to do some out. You can check them if you would like. And so here are the final 2 answers. The one thing that you will, or final 3 ones that we are going to do today. Excuse me, you'll notice that in this one, you'll see the difference of why you need to make sure you have du. We had du equals 2x. You needed to divide by 2 to get the dx alone, so therefore that's why we have a 1/2 out in front. I think this one, e to the x and e to the x, you add exponents. And so that is why we have e to the 2x here. E to the x and e to the x is e to the 2x, so that's why that one works. I think, though, everything else should make sense. Again, this is not the most important one. This, by far, right here, are the most important notes. I hope you guys have a good day, and I'll see you in class.